Alright, this next one, what we're going to do is we're going to evaluate this integral. So, once again, this is going to be one that turns out a little bit more difficult, because if we choose what we normally would choose, which is fine, we want to do that, it doesn't allow me to get this 2x plus 1. So what I'm going to have to do is I'm going to need to figure out, well, what is x equal to, and x is equal to u minus 4. So I'm going to need to rewrite this, and I'm going to have to rewrite this as 2. I'm going to keep the 2, replace my x with a u minus 4 plus 1 over, I made my u be square root of this x plus 4, so square root of u, and then my du and my dx can be interchanged because they're equal to each other. So now I hopefully will be able to integrate this, but I'm going to need to simplify this first. So I end up with 2u minus 8 plus 1 all over u to the negative first. I'm going to continue to simplify this. So I've got 2u, this would be minus 7 over u to the 1/2 du. I'm going to simplify it one more time by dividing each of these by u to the 1/2. So this will give me 2u to the 1/2 minus 7u to the negative 1/2 du. So I'll come back up here to go ahead and integrate this. So I'd have 2u to the 3/2 over 3/2 minus 7u to the 1/2 over 1/2 plus c. So that gives me 4/3 u to the 3/2 minus, I'd have 14u to the 1/2 plus c. The last thing I'm going to do is substitute those x's back in. So I've got x plus 4 here, so to the 3/2 minus 14. We can just write square root of x plus 4 plus c. It's a longer problem. This next one is for a definite integral. So I'm going to show you a little shortcut so we can do definite integrals much more quickly. We are going to change these bounds. So right now we have them in terms of x's. I'm going to pick my u to be what's on the bottom, and hopefully we end up with what we need because it makes things a lot easier. I get a 4x dx, so this seems to work out pretty well. I'm going to leave this integral right now. I'm going to just say this would be the integral of something over square root of u. I need an x dx, so I only need the x dx, so I'm going to move the 4 to the other side. So I put a 1/4 du in here. Now the problem with this and going ahead and integrating this is I want to teach you guys how you can just change your x bounds into u's. So what we're going to do is we're going to take this x bound and plug it in right here so that we can change it into a u. So u would be equal to 1 plus 2 times 0 squared. So that would be 0. 1 plus 0 is 1. So we'll change that bottom bound to be a 1. And now if you change this to be a 2, you now have 2 squared, which is 4, times 2 is 8, plus 1 is 9. So our new bounds are 1 and 9. What that does is it allows me not to have to change this back into x's at the end because I've now changed my bounds to be u's. So I have 1/4, the integral of 1 to 9, u to the negative 1/2 du. Let's go ahead and integrate this then. We get u to the 1/2 over 1/2. And we're not writing plus c because this is a definite integral. So this ends up being 1/2, because 1/4 times 2 would be 1/2, the square root of u from 1 to 9. I'll come up here to finish this. I get 1/2. And then I'm going to plug in 9 first, so I'd have the square root of 9 minus plug in 1, the square root of 1. So I have 1/2 times 3 minus 1, which would be 2, and 2 times 1/2 is 1. Now I am going to have one more example like this, and I'll do that on one more video, so it will be very short.